Mr. Anthony Gerard Santos is respiration rate and respiratory quotient of Musa acuminata AAA group bananas at various environmental conditions. You may now start your presentation, Mr. Santos.
Hi. Good afternoon. So to start things off, fruits are a major and essential component in people's diets. This is because of their significant health benefits to the human body. Thus, post-harvest practices are implemented to preserve the freshness of these fruits. Factors in post-harvest include the packaging, the temperature, and sanitation. There are thousands of fruits all around the world. However, for this study, we decided to conduct our research on bananas, specifically Lakatan bananas. Now, bananas are a major source of income and food in developing countries. And with that being said, the Philippines is one of the 5 leading banana exporting countries in the world. Here in the Philippines, you can buy bananas almost anywhere in the groceries, supermarkets, wet markets, and even in the streets. However, oftentimes we see bananas full of blotches, black spots, and bruises. Thus, companies applied the concept of modified atmospheric packaging. Modified atmospheric packaging helps modify the oxygen and carbon dioxide levels to maintain the freshness of the fruit. However, why is this concentrations important? Fruits undergo different biological processes, and one of them is respiration. Respiration is the process where organic compounds are oxidized. During this process, oxygen is consumed to maintain the metabolic activities which prevent the damaging of cells. Afterwards, carbon dioxide is then produced to the environment. The factors which affect the respiration is the temperature, the gas composition, the type of fruit, and the maturity stage. However, based on different studies related to the respiration rate, temperature was shown to have the most effect on the respiration rate of fruits. There are 3 different methods on how to measure the respiration rate of certain fruits, and they are the closed system, the flowing system, and the permeable system. The closed system stores the sample inside a gas-tight chamber and measures it in a gas analyzer. The flowing system, on the other hand, takes into account the flow rate of the gases as it flows from the container onto the gas analyzer. The permeable system takes into account the dimensions of the package. For this study, we applied the concept of the flowing system to measure the respiration rate. To explain how this works, here is a diagram which shows the flow of gases from this chamber onto the sensors. A banana sample is placed inside the gas chamber, wherein a fan is turned on to suck up all of the gases from the gas chamber onto the CO2 and O2 sensors. Afterwards, a fan is turned on for the gas concentrations to escape the sensors. To determine the respiration rate, we apply the following equations, where Y out is the measured concentration and Y in is the initial concentration. F is the flow rate of the device. We determine the flow rate through the fans, which were from the properties of the fans. Yes. Um, Another quantity which we determined was the respiratory quotient. The respiratory quotient is simply the carbon dioxide produced over the oxygen consumed. This ratio is significant since it determines the metabolic substrate being oxidized, where if the ratio is 1, it implies that carbohydrates are being oxidized, or if it's less than 1, it's lipids, and if it's greater than 1, it's acids. The objective of this study is to measure the carbon dioxide and the oxygen concentrations of the Lakatan banana in 3 various conditions: in a non-air conditioned room, in an air conditioned room, and in a refrigerator for 2 weeks. Afterwards, we calculated the respiratory quotient and respiration rate for each of those conditions. 5 samples of Lakatan bananas were tested for each of those conditions. Each of those bananas were measured of their initial weight and their final initial mass and their final mass after the 2 weeks. We also measured the temperature for each of the conditions using a weather anemometer. The following table describes the temperatures and the humidities for each of those conditions. Wherein in the air conditioned, we measured a temperature of 24 plus minus 2 degrees, a non-air conditioned 33 plus minus 2 degrees, and in the refrigerator 7 plus minus 2 degrees. Before we measured the concentrations for each of the conditions, we wanted to ensure that that the qualities of each of the bananas were good for experimentation. Wherein if the banana was too soft or dirty, bent, black skinned, showed black skins and blotches, was damaged or had a pigment of green, then we would have to find another sample of those bananas. The following are the bananas that we used for the experimentation. For the after the 2 weeks, we compiled the carbon dioxide concentrations and plotted it for 2 weeks. Based on our data, um, the non-air conditioned bananas showed the greatest variation, shown in the blue lines, where from the second day on to the third and fourth showed a very great increase in the carbon dioxide production. Similarly, the refrigerator, which is not too apparent, not too obvious, which is shown in the orange, showed also a slight increase on the third day. However, began to decline uh, along the following days. Um, based on a visual inspection on the bananas of the refrigerated bananas, they a discoloration appeared in the skin of the bananas early on due to the very low temperatures of uh, inside the refrigerator. Um, Significantly, for the air-conditioned room, on the other hand, showed the least amount of variation in the CO2 concentration, showing a steady production of concentrations within those 2 weeks. From this measurements, we were able to show that the temperature had a significant effect on the concentrations of the bananas. For the average O2, on the other hand, showed very low variations for each of the conditions. Now, by applying the equation of RQ, we were able to determine the average RQ for each of those days for the 2 weeks. Based on our data, the results showed that all of the RQ values were all less than 1, which, going back to the discussion of RQ, implied that lipids were the substrate being oxidized. The oxidation of lipids or lipid peroxidation is a common occurrence in foods, which causes the deterioration of such produce. If you notice for the non-air conditioned room, as it showed an increase in the RQ over the second onto the fourth day, which depicts a maximum oxidation in the lipids. However, after the fourth day, we noticed black spots which appeared on the surface of the bananas, which could imply that the bananas have begun to deteriorate, which can be shown from the decline in the RQ. Yes. Ay, dumoble pala. Now, before I discuss the respiration rate, I want to discuss 4 different phases which occur during ripening. During ripening, we experience a preclimactic minimum, a climacteric rise, a climacteric decline, and a senescence phase. I'll be showing it here. Here. This is the average respiration rate, which we were able to determine using the equation previously. As shown, the respiration rate of the carbon dioxide showed an increase. Initially showed a climacteric minimum on the second day. Following, it continued to rise and reached the peaks out of the peak on the fourth day. Afterwards, experienced a climacteric decline for the following days. The senescence means that the respiration of the banana um, experienced a gradual decline, which can be seen on the sixth onto the 14th day. Now, there's a sudden increase in the slight increase in the carbon dioxide concentrations from the 7th onto the 14th day. Based on a visual inspection from the containers, the bananas produced a viscous substance, which could have affected the measurements of the carbon dioxide. What surprised us the most was the respiration rate for the oxygen concentrations. The respiration rate for the oxygen concentration showed similar graphs to the CO2, showing an increase in the second onto the fourth day, onto the fifth day, and then continue the decline afterwards. This could imply that during the respiration rate of the carbon dioxide, the fruits ito dito, consumed more and more oxygen during this ripening phase. However, continued to decline as the um, CO2 declined as the CO2 declined. This sudden increase on the 9th onto the 14th day could imply since the CO2 concentrations began to stabilize in a very low rate, this could imply that the oxygen concentrations were how could I say this? Where a sudden increase in the oxygen concentrations were shown to have occurred inside the container. These are images of the bananas after the 2 weeks. Physically, the air-conditioned room showed the least amount of damage, wherein the non-air-conditioned room showed the very appeared to produce web-like substances and totally changed pigments from yellow to black. Now, in my conclusion, based on our study, we were able to show that the temperature had a major effect on fruits. However, the respiratory quotient and respiration rate has yet to reach the Filipino public, and by applying this, we could determine the maximum the points the amount of days before a fruit begins to deteriorate. This could be a stepping stone for further researches related to respiration rate and respiratory quotient. Thank you very much for listening.
Thank you, Mr. Anthony Santos. Are there any questions regarding the presentation of Mr. Santos? Okay, thank you very much, Mr.
Thank you.
Santos. Our next presenter is Mr.